Hey, so welcome to the third and final part of this part of the short series on immutable infrastructure. So what we're going to look at today is we're going to kind of take all of the things that we've looked at in the previous two videos, which is the basis of immutable infrastructure with Terraform, and also then using Packer to build gold master images. And what we want to look at is how we can do zero downtime upgrades with Terraform and Packer. So what do we mean by zero downtime upgrades? Well, by default, what Terraform will do is it will destroy any resources before it creates new ones. So in this particular instance, so imagine you've got a load balancer and you've got two droplets. You've got Web 1 and Web 2, and they're both the same application instance. And they're both running version 1 of your application. So if I decide that I want to change this image to the version 2 image, and I do a Terraform apply, Terraform's going to do something like this. So what it's going to do is it's going to start destroying the existing resources. That's going to leave you with a situation where you have an application which is unavailable. Later on in the lifecycle, Terraform's then going to start adding the new resources in there. Eventually your application is going to come back online and you're going to be back up to your new state, rolling on version 2. But this is undesirable because of that situation where we're going to have an application which is unavailable. There are some tricks which you can do with Terraform, and that's what we're going to look at in this video. So we're going to look at how we can change Terraform's default behavior to give us a situation like this. So we have those two same version 1 droplets, but this time with our modified Terraform configuration, we're going to change the life cycle in Terraform. So we're going to ensure that it's going to create resources before it destroys the old ones. And that's going to look something like this. So we've got our two existing ones. We update to version 2 and run a Terraform apply. Terraform is going to create our two new droplets. And once they're up and ready, it's then going to start removing the old ones. And by following this process, what's going to happen is you're going to have that zero downtime upgrade. There's going to be no interruptions whilst you're doing this rolling upgrade. So let's see how this works in terms of Terraform. So I'm going to use the same Terraform configuration that I've used in the last two videos. So what I have is a configuration which creates two droplets, so two DigitalOcean droplets called web. You can see there's two of them by the count of 2 there. And also I'm going to create a load balancer. So what I can do with the DigitalOcean load balancer is I can automatically attach droplets to the load balancer based on a tag. So here I'm setting the tag of zero downtime, and then inside my load balancer I'm expecting that zero downtime, and that's going to attach to droplets. So you can see over in my load balancer view, just in my left hand window there, that I have those two droplets and they are healthy. So if I quickly just start a ping on those, you can see that they're returning. I'm getting version 1 back, which is correct. And that's all fine. So what's next? So what's next is that I want to update this to version 2. So let me just change this to version 2. And what this is going to do is this is going to use the version 2 of my image, which I created just using that Packer template. And I can run that Terraform apply there. So I'm going to run Terraform apply. And I'm also going to run an Apache benchmark there as well, just so that we can throw some traffic through to this in addition to the little ping. So that's going to take a little while. So we can see that those droplets have been destroyed and the service is now currently unavailable. So what Terraform is now doing is it's creating those new droplets. You can see that the load balancer has marked those droplets as unavailable and they've gone, but we're going to have to wait some time for those new droplets to come online and for them to be reattached to the load balancer. And whilst we're waiting on that, our application is currently experiencing downtime, which is far from ideal. So let's just wait for that to finish and we'll explain how we can take a better approach. Okay, so you can see that we're now pinging this, and we're seeing version 2, which is coming through. And the load balancer in the DigitalOcean UI is still showing 2 down, but we do actually have those droplets created. So let me just stop that ping, and also let's just have a look at what happened with our Apache benchmark. So we were running that test, and Apache benchmark has received over 2,000 requests which were down, and that's just a concurrency of 5. So that's huge downtime. In terms of how long it actually took, we're looking at about a minute, 2 minutes. So that was 2 minutes downtime to upgrade those things, which again is far from ideal. So let's see if there's a better way to do it. So the first thing we need to look at is the life cycle. So I mentioned that life cycle in Terraform. So by default, the sort of the default behavior of life cycle is that Terraform will destroy a resource before it creates it. However, there is a meta parameter called life cycle, which is available on every resource. And what you can do here is you can configure things such as create before destroy. So this reverses that behavior. So it means that Terraform is going to create the 2 new resources, and once they've been successfully created, it's then going to go ahead and destroy them. So how we can use that is that we add this create before destroy. And let's just roll our version back to 1 and run our Terraform apply again. So let's just start that ping, Terraform apply. You can see that Terraform again is going to add 2 new resources, destroy 2. So I'm going to tell it yes. But what you can also see is that it's creating those resources first. So those resources are there. You can see them now inside of my load balancer. But we're getting a few of those service unavailables. And that'll be because the load balancer is just initializing with those new droplets. So we've destroyed the new droplets, we've created the new ones, but as you can see, we're still getting a lot of service unavailables there. And that's because the load balancer hasn't picked up the new droplets yet. It needs a little bit of time for them to be successfully registered. If we keep looking at that, wait for those to pass all of their health checks, and eventually they will, and they'll come back. Okay, so now they're online. So it was a little bit better, but we've still experienced downtime, so it's not ideal. What we need to be able to do is to do something which is almost completely seamless. So if we go back to our configuration, so we've added create before destroy, that helped. But we've also got the option of adding a provisioner. So let's think about provisioners. So a provisioner in Terraform allows you to do things like execute scripts, and you can do this either remotely or you can do it locally. Now, in terms of the resource life cycle, only if a provisioner successfully passes and completes will a resource be marked as successfully created. So in terms of how we think about that in terms of our 0 downtime, then we add this create before destroy. But if we add this provisioner step in there, then only when the node is marked as healthy will Terraform then progress on to the next stage, which is to remove the droplet which we're replacing. So it's a nice little way to be able to kind of add that lifecycle check into our Terraform configuration. So all I'm doing here is I'm just running check health, and I'm passing the IP address of the droplet that I'm creating. So my check health script is just a bash script, and all it's going to do is loop and it's going to wait for a 200 response. Now, this could be as complicated or as simple as you like, but I'm just using Bash. I've just got a very simple HTTP script here, so it's actually more than good enough. But we could be doing things like pinging the health check endpoint, or if it's gRPC service, we could be doing something a little bit more complicated around those lines. So let's go back to our main, and once we've added this additional step in there, let's now run our scripts again and see what happens this time. So we're on version 1. We're going to run our Terraform apply. Again, it's telling me it's going to create 2 and it's going to destroy 2. That's running. So the first one of our droplets has come up, and what's happening now is we're running our provisioning script. So Terraform's not going to destroy the existing droplet until that provisioning script comes back. So the provisioning script has run the health check and it's passed that that's available. It's just going to wait a little bit of time to make sure that the droplet gets registered with the load balancer and that the health checks are passing inside of the load balancer. And then it's going to proceed to destroy the old droplet. So we can see now that we're running a mixture. We've got both the type version 1s and version 2s. There was a little blip just as the load balancer would have been switching those things over, but it's nothing too bad. And we'll see from the Apache benchmark just how many actual requests we're losing. And once droplet 1 is finished creating, what you're going to see is we're going to see that roll over 100% over into the version 2 of our application. And there it goes. So we've completely transitioned over to our version 2 application pretty much with no loss of requests. So let's just quickly stop Apache benchmark and see what we've got. So across the time we were running that, and we were running continuously just pinging that public load balancer, we did drop 5 requests, and that will just be when the DigitalOcean load balancer is transitioning between healthy and doing its checks. But 5 requests is pretty decent, I think. And that's all there is to it. So just quickly to recap, all we're really doing is we're adding this additional life cycle. So we're telling Terraform we want to create the new instance before destroy. And again, this is a meta parameter, so it's available on every resource that's available within Terraform. And we're using this provisioner block. So we're just running a simple health check script, which is just pinging the public endpoint for our droplet and checking that we're getting a status 200 back. This could also be a remote exec if the droplets are not publicly available, but we're running in the private IPv4 network. And it could also be something more complicated than a bash script if you wanted to test something like a gRPC endpoint. But for now, that's it. So we're just concluding this part of the mini-series. The next section, we're going to start looking at things like security. So we'll take a little bit of a dive into HashiCorp Vault and how you can use Vault to secure your application secrets. And we'll also take a look at our new service mesh solution, which runs fantastically on top of DigitalOcean Kubernetes, which is Console Connect. So again, a short series of videos which will be security focused, but that's for the immutable infrastructure now. You can find the example project at the Terraform DigitalOcean lifecycle in my GitHub repository. If you've got any questions, please feel free to ping me in Hatch Slack. And thanks very much for watching.